Okay, so I've heard a lot about the POTA PERformer, and I kind of like to use an antenna which I call the L antenna, which we can see as a vertical with one radial, and I think it performs at least as good as the PERformer, as the POTA PERformer, or best. But I'll try to model the two and do a comparison and see what is best and what is easiest to deploy as well. So here, let's say this is the POTA PERformer. Let's say for 20 meters, so 5.1 meters up, 5.1 on this direction, 5.1 on this direction. Let's feed it in the center, so you can see. This shows it. So two radials, 90 degrees. Feed it in the center. Let's add 1 meter of height with copper wire and with a normal ground setup without radials. So let's see. SWR 2.44. We can adjust this quickly through the length of the first wire, for example, at the length of the two radials as well. Let's make them all equal. It's not the optimal solution, but it will work. Let's go for SWR. Try to optimize it. It's a bit slow on my MacBook Air because this is a Windows application. It's running through Wine, so it's searching for the best length. And yeah, I mean, with equal lengths we have a SWR of 1.4. That will be good enough for real world operation. So what can we see here? As expected, a bit more radiation in between the two radials. So how much is this? Let's calculate again. So we see laterally 0.6 dBs, and here in between the two radials 1.2 dBs at 26.4 degrees. So this is the PERformer. Now, my reasoning. So we can start by putting only one radial, like so, and same setup, 1 meter high, copper wire, no radials on the ground. Let's calculate like this. It's maybe too short. Let's see, 5.2 minus 5.2, 1.68. Okay, let's optimize for the purists over there. So position 2, associated 1 here for SWR. With only one radial you have a little bit less SWR. So 1.37, and what do we see? So 1 meter, the other antenna, the PERformer, is also at 1 meter. We see that it's in this direction that we have a little bit more gain, in the direction of the radial. So to be able to see it here, I will just put the radial on the x-axis, like so. And now if we calculate, it's the same, but the gain is coming here. So just to see the 3D model of it, so I'm I can be sure of what I'm saying. Yeah, so more radiation to the side of the radial. So, talking about numbers, we have 1.5 dBs at 27 degrees. So here we have maximum of what? I already forgot. So start. So here we have a maximum of 1.2 dBs at 26 degrees of takeoff angle, which we know it's important for the X, so the lower elevation the better it is. So this is the performer, 1.2 dBs, 26 degrees. And with only one radial, you have 1.47 dBs at 27 degrees. So 0.6 degrees of takeoff angle difference, which for me it's in real world it's the same. And a bit more gain between 1.2 and 1.47. It's not very different. So it's a lot less hassle to have only one radial to mount. Okay, so it's one support less, one wire less. If you have a linked performer, it's one radial less to tune to change links. If you want to change bands, so this is it. This shows that this is virtually the same. It will not change anything. But now I would like to explore another idea. And the other idea is most of us have like a 7-meter mast or a 10-meter mast. There are several 10-meter long masts that are good for portable because they collapse to 70 centimeters. And so it's very easy to have a mast that is 10 meters tall. So the question is, how can we improve the performance of the POTA PERformer with a 10-meter mast and easy deployment? Can we do better than this? And I think we can. And I'll show you the solution that I use, that I've used several times, and that works nicely. So I think I will start from this. So if we have a 10-meter mast, the vertical wire can start at 10 meter high. Okay, so to leave a bit of margin, let's say that the center of this antenna will be at 4.5 meters. Okay, so 4.5 plus 5.2, 9.76 meters at the top, which is a realistic height of a 10-meter mast. So now I've changed the height. Of course, the problem is if this is high, we cannot have a 90-degree radial, because we will need another mast of 4.5 meters to support this radial. So no problem. For this, my solution is easy. I go here, I put this at 45 degrees down, and I go from there. So if we start from here, I calculate this. We have 2.07 to 1 SWR, so we can again try to optimize this. And now is adjusting the lengths of the radial and the vertical section. Now we have a more reasonable SWR, 1.58. And what do we have here? So what we have here is an antenna that has a similar pattern that we saw before. Slightly less gain, 0.93, but 5 degrees lower. Okay. so 5 degrees lower. It's also more directional, and for me this is an antenna that, so there's a bit of a trade-off between ease of installation. Well, that's not what I want to say. That there is a bit of a trade-off between elevation, angle, and gain. Okay, but if you want to optimize for elevation angle, you need to put the antenna higher. Okay, so the radiation pattern looks like this. It's a bit directional, but still 180 degrees. We can see 180 degrees wide horizontally. Still a lot of gain, okay? Still around 1 dB gain, so the performer has 1.2. The performer is at 26.4 takeoff angle, and here we are at 22 degrees angle, so a lower angle, better for the X. Will you see real differences in real world? Maybe not. Maybe not, but I personally prefer this second solution because it's more directional. So if we see the diagram of the POTA PERformer, we see, yeah, it's basically the same, but it has more gain to the back than my solution. So we have a front to back of 0.65, and here on my L antenna you have minus 3.46 dB, so a lot more rejection. So if you are trying to work a specific direction with low takeoff angles, or the lowest possible for the height of your mast, you can think about using this solution. And for me the real advantage is, with a layout like this, you can just put like some meters of rope at the end of the element that goes down, and you just stick the rope on the ground. And for me, I think this is easier than having a separate 1 meter rod or mast or tracking stick to have a 90-degree angle radial. And I just like this solution best. I think a higher antenna is always better. It's always better to have a lower takeoff angle. And so this is what I use. Okay, I have different versions of this antenna, and what I think it's interesting in this layout is that if you elevate it even further for higher bands, for example, let's just quickly explore in the 10 meter band. So 28.5. Okay, this will be roughly 2.6 here, and on the other wire 2.6 as well. And this time, because we have 2.6 of length, we can put the antenna even higher on a 10 meter mast. So let's say we put it 7 meters high. Okay, 7 meters high to fully explore the 10 meter mast. So reasonable SWR, we have a higher gain, of course, and we see that, so it starts to be a bit more complicated because the antenna is more than half wavelength high, so we start to see different lobes. But the truth is we have a very low takeoff angle lobe at 1.7 dBs and 12 degrees takeoff angle. Okay, so an antenna like this, it's really good for the X, really good for the X, with a very reasonable gain and a front to back of 2.75 dBs, which means we are starting to see some real rejection of signals from the other side. If we compare this to the performer at for the 10-meter band, so let's go like this, 2.6 in here, 2.6, 2.6. We calculate SWR 1.5, 1.38 dBs, but the elevation is still 24.8 degrees, okay? And this is so the higher we go in bands, the better it is to go away from this design and adopt a design that is more like this and that is mounted higher on a 10-meter mast. Yeah, I'm focusing on the 10-meter mast because I think that is an easy thing to get, not too expensive, and perfect for portable in terms of height and transport length. So this is my thoughts, okay? We can see here we have another lobe on the L antenna that goes almost 3 dBs, higher takeoff angle, of course, but can also help to work more stations at different distances. So 1.3 dBs here at 12 degrees, and here 1.38 dBs, but 25 degrees. So this, I wanted to share this with you, just to open your mind in terms of, so the POTA PERformer is good, but it's not good for everything, for every band, and especially if you want to have a simpler setup, you can consider this L antenna setup. Okay, these are my thoughts today that I wanted to share. Thank you for watching, and see you again soon.